crystals and the use of the salt in our daily life. Okay, first thing you must know is the salt. What is the meaning of the salt? Normally, if the student do not study chemistry, the salt, the table salt, right? Okay, but if you are a chemistry student, you must know the salt, not only the table salt, the salt we eat. Okay, it has a lot of salts, okay, in our daily life. So what is the meaning of salt? A salt is a compound form. Okay, it is a compound form when the hydrogen ions in the acid from the acid is replaced with metal ions or ammonium ions. Okay. So meaning that to form the salt, you need the acid. For example, hydrochloric acid. Okay. It react with zinc. So the zinc, it will replace the hydrogen. Okay. So meaning that you form the zinc chloride. Okay. And the hydrogen gas. So times 2 here. So meaning that the hydrogen ions from the acid is replaced by the metal ions. So here metal ions is the zinc ions, right? So we call this is a salt. Okay. So any salt form is actually from the acid. The hydrogen ions from the acid is replaced by metal ions or ammonium ions. For example, sodium chloride, carbon sulfate, potassium nitrate, ammonium sulfate. All these are salt. Okay. Now, write the formula of this salt in the table of salt below by replacing the hydrogen ions in the sulfuric acid, hydrochloric acid, nitric acid, and carbonic acid with metal ions or ammonium ion. Okay. So here, there are 4 types of common salt we learn in the SPM level. Okay. Sulfate salt, it is from the sulfuric acid or sulfuric acid. Chloride salt is from the hydrochloric acid. Nitrate salt is from the nitric acid. And carbonate salt is from the carbonic acid. You see, all the hydrogen ions is replaced by the metal ions, okay, or ammonium ions. Okay. May I know yours is empty, right? Yes or no? Yours is empty. Okay. Now I would like you to try to write the formula. Actually, this one is the formula also. React with the salt. Okay. For example, I show you few. Okay, let's say sodium. Sodium ions, right? Okay, sodium ions replace the hydrogen, so it becomes the sodium sulfate, right? Then sodium chloride for the chloride. Then this one is sodium nitrate. This one is sodium carbonate. Yeah. Then the following one you can all try, okay, to write the salt. Okay, the salt. Please complete this table. I give you 5 minutes. Okay, everybody will try slow and steady, write the correct formula. Then this one becomes your table of salts. Okay. So now I hide first. Okay. So you try first. So 5 minutes. Okay, you hands on that. You try to write the correct formula. Okay, now we check all the formula. Okay, so for the sodium already. Okay, now you check for potassium. Okay, can you see it? Can you see the formula? Okay, no? Okay, you check one by one. Okay, potassium. So potassium sulfate, chloride, nitrate, carbonate. Okay. Now ammonium. Okay. See? Okay, then calcium. Sorry, magnesium sulfate, magnesium chloride, magnesium nitrate, magnesium carbonate. Okay. Then calcium sulfate, calcium chloride, calcium nitrate, calcium carbonate. Aluminium. Okay. Then zinc, and iron 2, iron 2, sulfate, chloride, nitrate, and carbonate. Then lead 2 sulfate, lead 2 chloride, lead 2 nitrate, and lead 2 carbonate. And copper, sulfate, copper, chloride, copper 2, nitrate, copper 2, carbonate. Then silver sulfate, silver chloride, silver nitrate, silver carbonate. Okay, and finally barium sulfate, barium chloride, barium nitrate, barium carbonate. Okay, finish already? That's all correct or not? Okay. Now, class, I would like you to highlight something. Okay. In this table, actually, it summarized out all the solubility also. Okay, there are some things that you need to remember for solubility, whether it's soluble in water or not. Okay, if you see my screen, okay, the one like a little bit blue, okay, like this one. Okay, sulfate, this one, and this three. Okay, for the sulfate salt, the one I highlight here, calcium sulfate, lead 2 sulfate, and barium sulfate. These three, they are insoluble in water. Meaning that if you put inside the water, you stir it, it still exists in the solid form. It will not soluble. Okay, these three. Others like zinc sulfate, iron 2 sulfate. Once you stir it, you put into the water, you stir, and then it will form a colorless solution. Is that okay? It was soluble, means the solid was soluble in water. Okay or not? For sulfate, it has three: calcium, barium, and lead sulfate. Okay, how about the chloride? Is lead 2 chloride, silver chloride. Okay, these two. Actually, another one is the mercury, but mercury is very, very seldom we use. Okay, you can note down is the mercury chloride, also insoluble. Also insoluble. Okay, these three. Okay. Okay, for nitrate, all the nitrate soluble. As long as you see all the nitrate, it is soluble in water. Okay or not? Okay, now? Okay. Meanwhile, for the carbonate, all are insoluble. Okay. All are insoluble except these three: sodium carbonate, potassium carbonate, and ammonium carbonate. Okay. All these sodium, potassium, ammonium salt, they are soluble. Like nitrate also. As long as you see sodium, potassium, ammonium salt, it is soluble in water. Okay or not? Other than these three carbonate, all are insoluble. Can or not? Can. So why we need to know the solubility? Because later on we are going to discuss the preparation of the salt in the lab. So you must know whether it is soluble or not. Then they have different preparation way or preparation method. Okay, so I will you can use any method so that you can remember. Okay, so I will normally I will put the first letter. For sulfate, I will put PBC, PBC. Okay, PBC sulfate. P is a lead sulfate, B is barium sulfate, C is calcium sulfate. So these three are insoluble. Other sulfate salt are soluble. Okay, how about chloride? Chloride, I take the first letter also, P, A, H. P is a lead, A is a silver, not aluminium. A is silver, Ag. H is a mercury. This one for chloride, insoluble. PaH, PbC, PaH. Okay, then nitrate all are soluble, and then this one carbonate all are insoluble except this one, SPA. This one take all SPA soluble, SPA are soluble. Okay, What is mean by ACBA? Sodium. This one is potassium. A is ammonium. Ammonium. Okay. These three are all soluble. No matter what it combined with, it is soluble. Oh, okay. This one's spend some time for you to remember. Okay, the solubility of the salt. Okay, huh? Later we will come back again to see the solubility for the preparation. Okay, now we go to the physical characteristics. Okay, how are the salt crystal formed? Okay, salt crystals are formed when a saturated salt solution is cooled down. Okay, what is mean by saturated? Okay, saturated salt solution or saturated in BM would be larutan tepu. Okay, what is mean by tepu? Or how to get the saturated solution? Normally is we heat. Okay, we heat strongly until left 1/3 left. Let's say the solution, okay, the solution initially is okay, roughly like this one. Okay, so this is the initial solution, salt solution. Okay, you heat it strongly. Okay, and then you evaporate, right? Okay, so it left around 1/3 left. Okay, meaning that this one gone. Left 1/3. Okay, you will see the salt crystal will form here. When it cool down, it will be a lot of salt crystal will be formed here. Okay, saturated salt solution. So example of salt crystal will be like this sodium chloride. This one is zoom in. Okay, carbon 2 sulfate calcium fluoride crystal. Okay, you see it's under microscope. Oh, then what are the characteristics of crystal? Okay, fixed geometry shape, flat faces, straight edges, and sharp angles. Fixed angles between the adjacent faces. Oh, okay, so not that popular. Okay, how are the soluble salt purified by recrystallization? Okay, how to purify the salt now? The insoluble impurities in salt solution are removed by filtration, whereas the soluble are removed by recrystallization. Okay, what is mean by recrystallization? Okay, so the soluble salt is dissolved in a suitable solvent, usually in water, meaning that the salt you get, right? Okay, you dissolve it in water. Okay, then the aqueous solution is then heated to evaporated until the solution is saturated. So again, saturated is roughly left 1/3, or left 1/3. When the hot saturated solution is allowed to cool, the salt reappear as a pure crystal, leaving behind the impurities in the solvent. So the crystal are obtained as a residue through the filtration. Okay, filtration. Okay, you turn not on this filtration. Okay, how to grow the copper 2 sulfate crystal? Okay, this one you can scan this and then you can watch the I think it's a YouTube video. Okay, how to grow the copper 2 sulfate crystal. Okay, it's like the crystal. Oh, you can have a look on this. Now, the salt in our daily life. Okay, like food preparation, like sodium chloride, MSG, sodium hydrogen carbonate, sodium benzoate, or sodium nitrate. Okay, all these. I want to mention about few things. Okay, actually a lot of the uses here already discussed under the acid and base, because acid and base normally after the neutralization you form the salt, so that will become the uses also. Oh, okay. So I don't emphasize a lot here. Okay, now let's go to the salt, preparation of the salt. Okay, under salt topic, okay, there are two parts you need to remember. First one will be preparation of the salt, preparation of the salt. Second part will be testing of the ions inside the salt. So it will be cations and anions. So now we look into the preparation of the salt. Okay, so the preparation of the salt is belongs, or we must know the solubility. So what are the classification of the salt? Okay, write down soluble salt and insoluble salt. Okay, soluble salt and insoluble salt. Okay, so general rules, just now I let you know already. So all the salts, sodium, potassium, ammonium are soluble. So this one, okay, revise again one more time. This one is SPA, SPA. S sodium, P is potassium, and A is ammonium. SPA. Okay. Then all nitrate salt are soluble, right? Okay. Then all carbonate are soluble, insoluble, sorry, except the SPA one, sodium carbonate, potassium carbonate, ammonium carbonate. Okay. Then all sulfate salt soluble, right? Except PBC, right? Okay, PBC. P is lead sulfate, B is barium sulfate, C is calcium sulfate, right? All chloride soluble except PAH, right? PAH. P is a lead carbonate, lead chloride. Okay. Then silver chloride, A, not aluminium, it's silver. Then another one is the H, is the mercury. Mercury. So based on the solubility, share the insoluble salt in the table. Okay. So just now I already shared with you. Okay. So experiment to do the solubility. Okay. So very simple. You find the salt and then put into the water, see whether stir it, and then see whether it is soluble or not. If it is soluble, means it is categorized as a soluble salt. If not soluble, so insoluble salt. Okay. Any question so far? Kind solubility, soluble salt. Soluble and insoluble, huh? Okay. Now, what are the methods to prepare the soluble salt? Okay, using the titration method. Okay, still remember what is mean by titration? Yeah? Anybody still remember what is mean by titration? Yeah? What is titration? Titration is the acid-base titration just now. Remember, we calculate the MAVA, that method. Okay, so you record down using the titration method. Okay, is used to prepare the SPA salt, SPA, soluble, means the sodium, potassium, and ammonium. Sorry. Okay, so any soluble salt, right, of sodium, potassium, ammonium, these three. So we are going to use the titration method. Okay, then other than this SPA, we are using the excess of solid reactants to acid. Okay, so later on we are going to discuss in details how to do the method number 2 here. Use the solid reactants add into the acid. Okay, now how about the insoluble salt? Okay, insoluble salt, we are using the precipitation method. Precipitation method for insoluble salt. Okay, so first you must remember the soluble salt, insoluble salt. Okay, then we need to know the method to produce the soluble salt and insoluble salt. Okay, now we look into the soluble salt part. Okay, so first one, use the titration method. When do we use the titration method? Okay, just now I let you know already. Salt of SPA. Okay, SPA, SPA. Okay. Okay, so if you look into the table, okay, meaning that all these three, all this, all this. Okay, sodium, potassium, ammonium, these three types of salt, all listed here are using the titration method. Okay, titration method. Okay, so in the titration method, is an acid react with alkali and produces salt and the water. So alkali is the best that's soluble in water and ionized to form the hydroxide ions. So if one of the aqueous reactants becomes excess, it is difficult to remove it by any physical method. Okay, so hence the titration allows the adding of acid to alkali until endpoint with the aid of indicator. The right amount of the aqueous solution react together without any one of them becomes excess. So meaning that there must be equivalent so that they will be easier to handle to form the salt later on. Okay. So any question you want to ask for this? Okay, huh? Okay. Now another one. Okay, other than SPA, salt. So we are going to soluble salt. We are going to use the excess of solid reactants to acid. So the solid reactants, quite many. Okay, we can use the reactive metals. We can use the metal oxide or metal carbonate. All can produce a soluble salt. Okay. So soluble salt here, which are not the salt of sodium, potassium, ammonium, are prepared by adding excess of the solid reactants acid. Okay. Can I? So titration only for spa. Okay. Write down for spa. Okay. SPA. Okay. This one is for soluble salt, except spa. Okay. Now, okay, class. This one is a basic concept first. Later on, we'll look into one by one. How are we going to do the preparation? Okay. And now, okay, this one is empty one, right? Okay, I'll let you try. Okay, choose the pair of reactants that require use of titration method or by adding the excess solid. Okay, here list to you 4. Okay, 4 example. Okay, so which one use the titration method? Which one use the excess solid reactants? Okay, quickly you put a tick and put a cross. Yeah, 4 example here. Choose the pair. Okay, already, class? Okay, done? Yes, okay, now check. Correct or not? Copper 2 carbonate with sulfuric acid. Okay. So what is the salt that you want to prepare here, actually? Plus, this one is the copper 2 sulfate, right? So copper 2 sulfate is not the spa one, right? So not the titration, right? So it should be adding the excess solid, right? Solid reactants with acid. Okay, then sodium hydroxide and hydrochloric acid is a sodium chloride, right? So sodium chloride, so you see under sodium, right? So it's titration method, not using the acid with the solid reactants, right? Okay, then how about this? Potassium hydroxide nitric acid. So you are producing potassium nitrate. Okay, so here potassium spa, right? Under spa. So use the titration method. Okay, then zinc with hydrochloric acid will be zinc chloride. So not the spa. So it will be using the adding excess of the solid reactants. Okay, all correct. Are you able to determine the method to prepare? Okay, this one is a basic one. Okay, basic one, and then we are going to discuss the preparation of the salt. Okay, the experimental one, the procedure. Okay, now how about the insoluble salt? Okay, so by precipitation method, precipitation reaction or method. Okay, remember the terms, precipitation or double decomposition. Okay, they are the same, precipitation or double decomposition. This is for insoluble salt. Okay, insoluble salt. So what type of reactants are needed for the method? Okay, the precipitate of insoluble salt is formed when two different solutions that contains the cations and anions of the insoluble salt are mixed. The precipitate is then obtained from by filtration class. Meaning that you have to get two different solutions contains the cations and anions. Meaning that the positive ions and the negative ions of the insoluble salt. Okay. So just now we have learned quite numbers of the insoluble salt, right? So for example, PBC, sulfate, PAH, chloride, right? Then carbonate, right? A lot of insoluble salt, right? So for example, just now sulfate. Okay, we take one example. There is a sulfate P, lead 2 sulfate. All right. Okay, so lead 2 sulfate. We have lead, we have sulfate ions, right? Inside the lead 2 sulfate is an insoluble salt, which is solid, insoluble. You forms the solid. All right. So you have to choose the two solution, which is one contains the sulfate ions, the anions. Another one contains the positive ions, that is the lead. Okay. You must choose both the soluble salt. Soluble salt, there is a solution. Okay. So lead 2 nitrate is a soluble salt. Sodium sulfate is a soluble salt. So when these two mix together, it forms the lead 2 sulfate and sodium nitrate directly. This one is very fast one. You see the white precipitate is formed. Okay. So how to deduce the correct reactants there? Okay. So for example, lead 2, right? Okay. So you can choose the nitrate, no? Because all nitrate soluble, correct or not? So meaning that any metal or the positive ion, you can combine it with the nitrate. Confirm it is a soluble salt, right? So lead 2 nitrate, easier. Then for the anions, always combine with the SPA, sodium, potassium, ammonium sulfate, you get the soluble salt. Is that okay? So once you get the insoluble salt, this one is soluble, right? Then you can filter it to get the solid here. Then you can get the insoluble salt. Okay, so it is advisable to suggest the reactants in which one is the nitrate salt. Another one will be salt of ammonium, potassium, or sodium, because they are always soluble. Okay, so ionic equation, we will focus to the here. Okay, the insoluble salt, lead 2 sulfate, lead 2 sulfate. So the ions will be lead 2 ions and sulfate ions. So it forms a lead 2 sulfate. Okay or not, class? Okay, Can follow so far? Can, Okay, now let's try this table. Okay, we try to do one together. Okay, later I'll let you try. Okay, let's say now I want to prepare the lead 2 iodide, which is insoluble salt, is a solid. So we need to choose two solution. Okay, two solution. So solution of cations which contains the lead 2 ions. Okay, any suggestion? What is the solution we can choose? Yeah, class. What solution we choose? Any suggestion? Contains the cations, which is the positive ion. The lead, no? Any? you can refer to the guidelines here. Let the metal ions, right? Okay, the positive ion always combine it with a nitrate, right? Okay, so meaning that we can choose lead to nitrate. No? Okay, okay on that class. Can hello class. Okay or not? Okay, huh? Okay, how about the anions? Anions now is iodide, no? Okay, I use the colors lead 2. So lead 2, I choose the lead 2 nitrate soluble. Okay, how about the iodide? What solution should I choose? Contains iodide. Yeah. Anyone? Please suggest one. Contains anions. Can or not, class? Okay. Sodium iodide. Iodide, no? DE. Okay. Yes, sodium iodide can. Sodium iodide. Okay. Also can choose what? Beside sodium, you can choose potassium iodide, right? Okay. You can choose ammonium iodide also. Okay. Because all are soluble, you must choose the soluble one. Okay, we choose the soluble one. You cannot choose the insoluble one. So, but always refer here. If positive, you combine with nitrate. If negative, you combine with these three. Confirm a correct one. Okay. Then, how about the ionic equation? You want to form the lead 2 iodide, right? So, what ions? Lead 2 ions and iodide ions. Okay. So, this is a ionic equation. Okay. We try another one. Okay. Let's say silver chloride class. Silver chloride. So we must choose two solution, right? Okay, two solution mixed together, you will get the insoluble salt immediately. So we need to choose what? One is the silver, another one is chloride. Okay, suggestion class. Silver what? Silver nitrate, no? Very good. Okay, how about the chloride? You can choose sodium chloride, no? Or potassium chloride. Yes, or ammonium chloride. Okay. As long as it's three. Okay, now the ionic equation, we want to find get the silver chloride, right? So it's the silver ions and then the chloride ions. Okay. Now there are two. Okay, barium sulfate and calcium carbonate. Okay. So can you try to complete this two row here for barium sulfate and calcium carbonate? Barium sulfate. Okay, what is the solution of the ions you need? You can type your answer here. What have you, right? Barium nitrate. Yes, barium nitrate. Okay, how about the sulfate? Okay, sodium sulfate can. Okay, sodium sulfate, for example, sodium sulfate. Okay, ammonium sulfate can. Ammonium sulfate. Okay, another one, potassium sulfate. No? Okay, so the half equation, barium ions, sulfate ions. So it forms the barium sulfate. Okay, correct or not, class? Okay, now? Now calcium carbonate. Okay, what is the solution of cations? I think this one should be okay, right? Okay, calcium nitrate. Yes, calcium nitrate. Okay, then this one anions, carbonate. Okay, again, sodium carbonate. Okay, ammonium carbonate. Okay, or potassium carbonate. Okay, so the half equation, calcium and carbonate. So produce the calcium carbonate. Determines the method to prepare the salt. Okay, so now I will summarize. Okay, do the summary for this preparation of the salt. Okay, so preparation of the salt, there are two. Okay, two types. Okay, so the first one is a soluble salt. Okay, another one is an insoluble salt. Insoluble salt are relatively easier. Okay, so using the precipitation reaction, the one we discussed just now, or we also call it double decomposition. Okay, so here for double decomposition, we just mix two solutions. Mix two solutions contains the cations and anions of the insoluble salt. Okay, then stir with the glass rod and filter using the filter funnel, and then rinse the residue with the distilled water and then dry them between the two filter peppers. This one, filter peppers, at least two. If filter pepper, no S, will be -1 mark. Okay, so remember, must be filter peppers, at least two. Can be 3, can be 4, but cannot be 1. Okay, so this one is a reminder for you. Okay, so this one no need heating, no heat. Okay, no need to heat the salt. Okay, now for the soluble salt. Okay, so this one salt of SPA, SPA. Okay, this one is the non-SPA. So for SPA method 1, okay, so use the titration method, acid with alkali. Use salt and water. So actually, this is the titration method. Titration method. Use the burette one. Burette one. Okay. So here, the titration is conducted to determine the volume of acid needed to neutralize the fixed volume of the alkali. Okay, with the indicator. So first round, you need the indicator, but you need to repeat it. Okay, repeat it without any indicator. Second time. Okay. So after you do this one, okay, then you need to heat. We call it evaporated, the filtrate until it becomes saturated. Okay, saturated means very, very concentrated. Okay, how do you know it is saturated already? So normally you record down left 1/3 of original solution. Okay, tinggal 1/3 saja. Then dip a glass rod. If crystals are formed, the solution is saturated. You will see the salt crystals. So crystals are formed. Okay, then let it cool down to room temperature. Then filter it and then dry the salt crystal by pressing them between filter peppers. Okay. Now, if non-SPA salt, we use this one. Okay. So there are 3. 1, 2, 3. Okay. So this now acid with metal. So this one accept what metal? Accept copper and silver. Okay, except this two. Cannot use the metal here. Okay, so if copper, meaning that you have to use this one or this one. Okay or not? Okay, then you add in the metal oxide or metal carbonate, powder in until excess or until excess in a fixed volume of acid. Acid, you need to heat it. Then filter the mixture to remove the excess metal oxide or metal carbonate. Okay, so this one we put excess into the acid to ensure acid is fully reacted. Okay, that's the reason to put them in the excess. Oh. Okay, so now, okay, I'll give you some example. Okay, so now method 1, method 2, and method 3. There are 3 methods. Okay, so you just let me know which method. Okay, method 1 is this one, the SPA question, SPA solution. Okay, to produce the SPA salt. Method 2 is non-SPA soluble salt. Method 3 is the insoluble salt. Okay, so now, okay, let's try. Okay, the first one. Which method are you going to use? Okay, so let's say now is a copper 2 nitrate. Okay, so this one, which method are you going to use? Which method? Method 1, 2, or 3? Class? Is it soluble? Okay, so you ask, is it soluble? Yes, right? Nitrate must soluble. Then is it SPA? SPA? No, right? So you have to use method 2, right? Okay, so method 2. 2, okay, method 2. So method 2 got 3 way for us to do the reaction. Okay, so which one can use? We can use 1, 2. Can we use the first one? Acid with copper. So we can use can we use the nitric acid with copper? Can or not? The answer is cannot. Cannot, Cannot. No. Why? Because here I mentioned already, except this one, copper and silver. Because they are not reactive. Tidak reactive. Tidak reactive. Okay. Other metals can, like zinc, magnesium, okay. But copper cannot, cannot. So we can use the method 2, nitric acid with copper 2 oxide. This one can. Or nitric acid with copper 2 carbonate. Okay, can. Now I give another example. Okay, let's say, okay, zinc carbonate. Okay, so class, which method are we going to use? Zinc carbonate. So you have to answer, is it soluble or insoluble? 2 means this one, soluble. Is it? Okay. Zinc carbonate, is it soluble, class? You have to ask. Carbonate, class? Carbonate. No, right? Carbonate salt is a non-insoluble salt, right? Except the SPA. All carbonate insoluble, remember, So it is insoluble salt. So this one is insoluble salt. Okay. So insoluble, So remember, if you assume it is a soluble salt, then you will choose the method 2, but it is the insoluble salt. So okay, so it is important for you to first hand. You must remember it is soluble or not soluble, huh? So insoluble, so meaning that we have to use the method 3 law, okay? Or Emery, Crystal, and then Willie, huh? Just now, okay? You respond to it now, okay? Good one, okay? So in class, wrong, never mind, huh? We always can discuss. In exam, okay? We try our best in the exam, huh? Okay, so it's method 3. So we have to use 2 solutions. If zinc carbonate, okay, recall back. What are the 2 solutions we can use? One contains the zinc, one contains of carbonate. Okay. So any idea, class? Zinc what? Nitrate, right? Or choose nitrate lah. And then for carbonate, we choose the SPA, right? SPA. Like say you choose ammonium lah. Just now all the example we didn't choose ammonium. So ammonium, ammonium carbonate. So you form the zinc carbonate with ammonium nitrate. Okay. Okay, so class. So I think almost the time. Okay, so today, okay, what you can do. Okay, first thing, you remember the insoluble salt, the soluble salt. Okay, here, this one the rules. So you must determine whether it is soluble or not first hand. Okay, I'll spend some time to remember, to remember. Okay, so actually, not difficult for chemistry. Okay, for chemistry, these chemicals are fixed. Okay, teachers, for me, I also need to memorize things every year. Why? Because all my students are new, so I need to memorize your own names, right? It's a challenge for me also. Okay, for me, remembering student names will be more difficult compared to all these things. Okay, so my challenge also. Okay, your challenge is memorizing the chemicals one. Chemistry, names, soluble or not, okay, the charge and so on. That's your challenges. Okay, so set for yourself. Okay, memorize it. Okay, after that, you know the soluble or not, insoluble or soluble salt. Then we determine the method to prepare it. So this one is a basic one. So in the classroom, okay, so when we can go to the lab, so we can directly do the experiment to prepare the salt. Okay, otherwise I need to explain the concept again in the classroom, so we have less time to do the experiment. So in future, I will from time to time I will conduct a class like this to explain the theoretical. Okay, so when we come to the classroom, we can directly do the experiments. Okay, on that class. So for this one, okay, so this one actually you can refer to the textbook. Your textbook, I think you have. I haven't checked. I think you can get the answer. You try to fill in the blanks for this. Okay, this is for the method 2, soluble salt except the sodium, potassium, ammonium, or this part. Okay, but the right side part, okay, this is for the method 1. Okay, so some of the steps actually are repeating. So you can see these diagrams. So okay, so the steps are like this. So you fill in the blanks. Okay, and then this one is for the insoluble salt. Okay, preparation of the insoluble salt or double decomposition reaction, precipitation reaction. Okay, so this one is easier. Okay, so we are allowed to go to the lab next week. Okay, so this week still cannot. So next week we can go to the lab already. So we can do the experiment. Okay. Okay, so for this one, okay, page fill in the blanks for this one, and then this one, okay, plus this one. So to test yourself whether you understand what I'm talking about this morning, 1 hour roughly. So you write down this is soluble or insoluble salt. IS means insoluble. Okay, then write the chemical equation, all the possible chemical equation. Okay, For example, let's say for the non-spark soluble salt, it has 3, right? Or if it has 3, you list out all the 3 chemical equations. So this one I would like you to try, huh? Everyone here, okay? You try this, okay? For this, the page is slightly different with yours, huh? Okay, I think you all got this one, huh? Oh, okay. So this one I will let you do as a exercise, huh? Okay, to test yourself.